Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 21, Transformations of the Quadratic Parent Function f of x equals x squared. So in this lesson, the student outcomes will be students make a connection between the symbolic and graphic forms of quadratic equations in the completed square vertex form. They efficiently sketch a graph of a quadratic function in the form of f of x equals a times the quantity x minus h squared plus k by transforming the quadratic parent function of f of x equals x squared without the use of technology, no calculators. They then write a function defined by a quadratic graph by transforming the quadratic parent function. Okay, so let's get started here. So classwork example 1 says, quadratic expression representing a function. A quadratic function is defined by g of x equals 2x squared plus 12x plus 1. Write this in the completed square vertex form and show all steps. Okay, so the function g of x equals 2x squared plus 12x plus 1. The first thing we want to do, step 1, is to gather the variable terms, group the variable terms. So this has a variable x, this has a variable x, this is the constant. So we're going to put a parentheses around the variable terms and leave the constant outside. So it's going to look like this. We're going to take g of x equals parentheses 2x squared plus 12x, and then close the parentheses and put plus 1 outside here. So what we're doing here is breaking this into two terms broken up by this plus sign. So we have this binomial by itself, and then we have this constant over here. The next step is to factor out the greatest common factor of what's in the parentheses. So that's going to look like 2 will go into 2 and 2 will go into 12, and there's also an x. We're not going to factor out the x though, because what we're trying to do is make a complete square. So we're just going to factor out the greatest common factor numeric portion. So the 2 is going to come outside. So 2 divided by 2 is 1x squared. 12x divided by 2 is 6x. And then plus 1. So if I were to distribute this, I'd get back to what I started with. So the 2 does not get distributed to this constant 1 out here. And that's why we took that 1 out in the first place. So step 3, we're going to complete the square by taking 1/2 of b and squaring it to make a c. So let's just change color here because I want to point something out what's going to happen. So if that 2x squared plus 6x is going to stay there, but I'm going to take half of this 6, which is 3, and square it. Well, 3 squared is 9, so that's going to be plus 9 over here. Okay, so this is what I have now. But I can't just add 18 to this right side and not add anything to this left side. It would no longer be equal. And you're probably saying, well, where's the 18 coming from? Well, if I distribute now, 2 times 9 is 18. And that 18 just appeared there. So since I put 18 in, if I negate it out here, do the inverse of adding 18 by subtracting 18, this whole thing is plus 18 minus 18 is 0. So this is all still equal to the previous term. Or previous function, I should say. Okay, so now that I've done that, I have a perfect square inside the parentheses. So this 2 is going to stay here. And then I'm going to represent this as a perfect square. And it's going to be x plus 3. Okay, so the term that ends up in here is going to always be half of our b term. And it's going to be the square root of our constant term. So then I put this squared up here, and if I FOILed this, I would get x squared plus 6x plus 9. So now I have an x plus 3 squared, and 1 minus 18 is 17. Okay, So now I have g of x equals 2 times x plus 3 squared minus 17. Okay, so that tells me where the vertex is. Now that I have this in, let me put this down here now. So now I have g of x equals 2 times the quantity x plus 3 squared minus 17. So keep in mind that this is my h and this is my k. So the vertex is the point h comma k. Well, it's x minus h. So if h is 3, then it's going to be x minus a negative 3 to make that positive. So remember, it's always opposite sign when we're in parentheses. So it's going to be negative 3 comma. The 17 is not in the parentheses, so I use the same sign, which is minus 17. So this quadratic has a vertex at the point negative 3, negative 17. Okay, part C says to look at the completed square form of the function, can you name the parent function, and how do you know? Well, the parent function would be f of x equals x squared. And the how do you know part is, well, it is an x squared, so that's an ax squared plus bx plus c. That is a quadratic function, and the parent function of a quadratic is its simplest form where a is 1, b is 0, and c is 0. So the parent function of the quadratic is just simply x squared going through the origin. Part D says what transformations have been applied to the parent function to arrive at function g and be specific. Okay, so it was, this is a translation 3 units left. This is a translation 3 units left. This is a translation down 17 units. This is a vertical stretch of 2. Okay, so the parent function f of x equals x squared is translated 3 units left, that's this right here, stretched by a vertical factor of 2, that's this red 2 right here, the original 2, the a, and the translated 17 units down, which was our c. E says, how does the completed square form relate to the quadratic parent function f of x equals x squared? Okay, so you would say the completed square form can be understood through a series of transformations of quadratic parent function f. Okay, page 2 brings us to example 2. The graph of a quadratic function f of x equals x squared has been translated 3 units to the right, vertically stretched by a factor of 4, and moved 2 units up. Write this formula for the function that defines the transformed graph. Okay, so let's just underline the given or highlight or whatever. You always should do this. So they're given the parent function f of x equals x squared. 3 units to the right, vertical stretch by a factor of 4, moved 2 units, oops, Control Z, move 2 units up. Write this formula as a defined graph. So it would be g of x equals, well, your a is your stretch. Vertical stretch by a factor of 4 would be 4. Parentheses, x. 3 units to the right is, left-right is opposite in the parentheses. 3 units to the right, so it would look like x minus 3 quantity squared, and a vertical stretch by a factor of 4. So that's this, and move 2 units up. Up is plus. So it's g of x equals 4 times x minus 3 quantity squared plus 2. Okay, now we're on to the exercises. Without using a graphing calculator, sketch the graph of the following quadratic functions on the same coordinate plane using transformations of the graph of the parent function f of x equals x squared. Okay, so they're giving us 5 transformations. Here's the parent f of x equals x squared going through the origin, quantities squaring. Alright, so I'll start with black, and I'll do this in black. So the negative 2 tells me it's going to get flipped. The first thing I want to do is find the vertex. left, minus 3 is right 3, up 4. So if I go over 3, up 4, the vertex of g of x is right there. The vertical stretch of 2 would make it narrower, and the negative will flip it upside down. So as I went over 1 here, it went up 1. So I'm going to go over 1, I'm going to go down 2. I'm going to multiply that by a factor of 2. So I go over here, picture the vertex, the axis of symmetry right here, x equals 3. And then if I went to 2 here, this went up 1, 2, 3, 4. Well, 4 times 2 is 8. So if I go over 2, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. Over 2 to my axis of symmetry, over 2 more, and that would be right there. So then I would draw a curve here. So I'm going to try that off screen. Okay, so there's the function graphed. That is g of x. So I'll change colors to green, and I will do part B now, right here. So we always want to find the vertex first, so that would be left 5, up 1 from the origin. 1, 2, 3, 4, 5, up 1 is right here. So there's our vertex. Axis of symmetry is x equals negative 5. Okay, and it's a vertical stretch of 3, and it's flipped over the x-axis because of the negative. So instead of going over 1, down 1, I'll go down 3. Over 1, down 3. And if I did that again, this was over 2, up 4. So over 2, 4 times 3 is 12. I'd be way down off the graph. So there's the only 2 points I'm going to plot for now. And then I will draw the graph through the points. Okay, so it'll look something like this. So let's move on to blue. And I will do part C. Vertex is negative 4, negative 3. Left 4, down 3 is right here. It's shifted 4 left, down 3. It's positive, so it's opening up, and it's a vertical stretch of 2. So instead of going over 1, up 1 like the parent did, I'm going to go over 1 times a multiple of 1, which is there, and do the same on the other side of the axis of symmetry, which is negative 4. X equals negative 4. So then I went over 2, up 4. Well, this is going to go over 2, up 4 times 2, which is 8. There's 3, and 5 more is 8. So it would be here, go over 2 to the axis of symmetry, and over 2 more. And there are my points, and I'm going to draw that. Okay, so there's the graph of k of x in blue. And we'll move on to purple for D. And D is p of x equals x squared minus 2x. Okay, this is not in vertex form, so I need to put it in vertex form. So remember, the first thing we do is factor out the common factor, which there isn't one because a is already 1. So I'm going to put a parentheses here and put an x here and close the parentheses. And it's going to be minus, remember that parentheses, it's going to be minus 2x. And to complete this square, I have to take 1/2 of 2, which is 1, and square it. 1 squared is 1, so I'm going to put plus 1 here. That will complete the square of inside the parentheses. But since I added 1 to the inside, and that I have to subtract 1 on the outside from my k. And since k was 0, now it's going to be minus 1. So now this is a perfect square. So now I can write this as x minus 1 squared minus 1. Okay, so if I foiled this, x times x is x squared. Okay, there should be a squared here. X squared. Outer would be minus 1x. Inner would be minus 1x, giving me minus 2x. And a negative 1 times a negative 1 is positive 1. So there's my vertex. My vertex is now 1 comma negative 1. So this is a shift right 1, down 1. So right 1, down 1 is right here. There is no a other than 1, so it's just over 1, down 1. Oh, not down, it's up. A is not negative. So it's over 1, up 1. Over 1, up 1 is here. left 1, up 1 is here. The original parent function, if I went from the origin over 2, it went up 1, 2, 3, 4. So I'm going to do the same here. Over 1, 2 from the vertex, up 1, 2, 3, 4, which is right here. Over 2, up 1, 2, 3, 4, which is right here. And then do one more. Or I don't have to, let me just graph that. Okay, so there's p of x, shifted 1 to the right, down 1. And that's it. Alright, so let me just erase my work here. And now we're going to do E. I'll do that in red, I guess. So E will be done in red. Again, it's not in vertex form or standard, or vertex form, so I have to do that. So it's t of x equals x squared minus 2x quantity, put the constant outside, and then factor out anything, but a is already 1, so I'm not going to do that. So the next thing is complete the square. Half of negative 2 is negative 1. Negative 1 squared is 1. Since I added 1, I have to subtract 1. So it's plus 3 minus 1. So that's going to equal x, and it's going to be minus 1 squared. That's what this is. And 3 minus 1 is 2, so that's going to be plus 2. So it's shifted right 1, up 2. So if I go right 1, up 2, I thought this was in red. Right 1, up 2, that would be right here. There's my vertex. A is 1, so it's just going to be over 1, up 1. And on the other side as well. And over 2, up 1, 2, 3, 4. Over 2, and we are right here. Okay. And there is the graph of t of x in red. Okay, so those are all the transformations of the parent function f of x, as indicated. Okay, page 3 brings us to problem number 2. It says to write a formula for a function that defines the described transformation of the graph of the quadratic parent function f of x equals x squared. So we're given this parent function, and we're going to find a transformation of that. So I'm going to say g of x equals. So I'm going to leave space for an a, parentheses, x, leave space for h, and then k will go over here. So a, 3 units shifted to the right. Well, that's my h. 3 units shifted to the right. Right being in the parentheses is going to be a negative. So I'm going to write minus 3. And that's going to be squared. So that's where a came from. Okay, so b now says a vertical shrink by a factor of 0.5. Well, that is my a. So a shrink by a factor of 0.5 will go right there. A reflection across the x-axis is also an a, making it negative. So that's going to be a negative 0.5 a. And then part D, 4 units up, would be plus 4. So let me just rewrite this now. So it's g of x equals negative 0.5 quantity x minus 3 squared, and then plus my 4. Okay, so now it says, then graph both the parent and the transform function on the same coordinate plane. So let me graph the parent in red. Okay, so the parent in red is f of x equals x squared. The vertex is 0. 1 squared is 1. Now keep in mind I didn't write numbers down here, but this is in units of 1 per square, 1 unit per square. So 1 squared is 1, 2 squared is 1, 2, 3, 4. And 3 squared is 4, 5, 6, 7, 8, 9. 3 squared is 9. Now this repeats on the other side of the axis of symmetry, which is my y-intercept, or my y-axis, because my x equals 0 is my axis of symmetry. So over 1 more, put a dot there. Over 2 more, put a dot there, over 3, over 3, put a dot there. Okay. Okay, so there's the graph of my parabola, if you will. It's pretty sloppy, but it's hard to draw with this pen. All right, so now I'm going to do g of x in blue. So g of x in blue, well, where's my vertex? Right 3, up 4, 3 units right, up 4. That's the point 1, 2, 3, 1, 2, 3, 4. That is right here. It is a flip, and it's going to be a shrink by a factor of 0.5. So that's going to spread it out. It's going to compress it. So instead of going over 1, down 1, I'm only going to go over 1 and down a half. And I do the same on both sides of the axis of symmetry, which is x equals 3. So that's my first set of points. So this one went over 2, up 4. So I'm going to go up half of that because 0.5 is half. So I'm only going to go over 2, down 2, which is here. Over 2, down 2, which is here. And then finally, I'll do one more point. This was over 3, up 9. So this is going to be over 3, down half of 9, which is 4.5. So 1, 2, 3, down 1, 2, 3, 4, and 1/2 would be right here. And do the same over here. And that would be right here. Okay, so the parent is in red, that's f of x, and the transformation, or the is the blue one, g of x. Part 3 says, describe the transformation of the quadratic parent function f of x equals x squared that results in the quadratic function g of x equals 2x squared plus 4x plus 1. Okay, so what do we have to do? Well, we've got to put it in vertex form. So, whoops, nope. Okay, so we're going to choose a different pen. There we go. All right, so it is going to be g of x equals, remember the first step, put your variable terms in parentheses and put your constant out by itself. Step 2, factor out the numeric portion. So 2 and 4, and 2, the greatest common factor of 2 and 4 is 2. That will leave me with x squared plus 2x, and then plus 1 out here. And then we take half of b, which is 1, and square it. 1 squared is 1, and that goes here. Okay, and let me just color code that. So we have this plus 1 here, and we have this 2 out here. 2 times 1 is 2, so we're really adding 2 to this, so I need to subtract 2 out here to make it equal. Plus 2 minus 2 is 0, and it would be like not changing anything at all. So finally that will give us 2x plus 1, quantity squared. So all you're doing is taking the half of b, and that goes here. And 1 minus 2 is negative 1 or minus 1. Okay, so now that I have g of x in vertex form, I now know that it's shifted left 1, down 1, and a vertical stretch of 2. Okay, so this means that the graph of f is translated 1 unit to the left, that's right here, vertical stretch by a factor of 2, and translated down 1 unit. Okay, page 4 brings us to problem 4, and it says to sketch the graphs of the following functions based on the graph of the function f of x equals x squared. So that's our parent, right? So the parent function is a quadratic. So there's our parent. If necessary, write some of the functions in vertex or completed square form and label your graph. So this is already in vertex form. A I'll do in black. So this is just the same as before the example. You should be trying this, by the way, on your own, pausing the video and then coming back and checking. And so now here's the solution to what you hopefully have already done. So minus 4 plus 3, that's right 4 up 3 over 4 up 3. There's my vertex. That is going to be flipped over. That's what the minus does. And no stretch. Okay, so over 1 down 1 instead of over 1 up 1. This went over to up 4. This will go over to down 4. And same on the other side of the axis of symmetry. And then this went up over 3, up 9. This will go over 3, down 9, which would bring us to negative 6. Right here. Okay. And then go over 3 to the axis of symmetry, over 1, 2, 3, and there are the points. I'm not going to draw the lines this time. You can see where it's going to be. And I will move to B now. Right 2, down 1. So from, let me not use red, let me use green. So this is right 2, down 1. So from the vertex at the origin of the parent, you go over 2 to the, right 2, down 1. Right 2, down 1. There's my axis of symmetry, is x equals 2. My vertex is 2, negative 1. And it is a stretch of 3, and it's opening upward because it's still positive. So over 1, up 1, 2, 3 would be here. Over 1, up 3 would be here. And this was over 2, up 4. This would be over 2, up 12. So I'll be off the screen, so it's going to be up here somewhere and over here, up here somewhere. So you can see now it's a parabola. Shifted to the right 2, down 1, and then stretched. All right, part C. It is not in vertex form. So I'll do this over here. K of x equals, and you group the variable terms. There is no constant or k, so that's it. Step 2, greatest common factor, numeric, 2 and 8. 2 will go into 2, 2 will go into 8, and that will leave me with x squared plus 4x when I factor. Okay, I'm going to run out of room here, so I'm going to move this down now to the bottom. Okay, so here I am, down here. All right, so now I need to take that, k of x, and I will color code to keep this straight. The 2 stays. X squared plus 4x, and I'm going to take half of 4, which is 2, and square it, and that's going to be plus 4. So the reason I did red was to show you that when I distribute this, that is actually 2 times 4, which is 8. So if I add 8 to the right side, I also have to subtract 8. Okay, so now I can just complete the square, or make it a perfect, I made it a perfect square, so now I can just say this is 2 times the quantity x, and my b was, half of b was 2, so it's going to be plus 2 quantity squared minus 8. Okay, so there's my k of x. So it's left 2, down 8 from the origin. So left 2, down 8. Well, that's not a very good graph they gave us, is it? Okay, that should have gone to at least negative 8. So I'm off the grid here. So here's my point. And then it is opening up, and it's a factor of 2. So instead of over 1, up 1, I'm going to go over 1, up 2, and that would be here. Instead of going over 2, up 4, I'm going to go over 2, up 4 times 2, which is 8. So over 2, up 8 would be at the origin. Go over 2, and I'm on the other side of the vertex, so it would look like that right there. Okay. And then finally, p of x, I will do in purple. P of x is also not in standard form, or vertex form, I mean, it's in standard form. So I'm going to do that over here. Let me move this out of the way. Okay, so I moved this out of the way so I could do part D in purple down here. So it's p of x equals, I have x squared plus 6x plus 5. I'm going to put the variable terms in parentheses, step 1. I am then going to factor. A is already 1, so I don't need to factor. So there's not going to be a vertical stretch. or compression, or a flip. It's just going to be shifted left, right, up, down. So I'm going to complete the square. Half of 6 is 3. Half of 6 is 3. 3 squared is 9. So I'm going to put plus 9 there. Let me do that in a different color. So it's going to be plus 9. All right. So that's 6x. And then switch to red, plus 9. This is not being multiplied by a factor outside, so I'm just going to subtract 9. Okay, plus 9 minus 9 is the same as not being there at all. And then finally I have a completed square, so the perfect square, that should be squared here, is x. Half of 6 was 3, so it's the half of b that goes there, squared. And then plus 5 minus 9 is minus 4. So that is a shift left 3, down 4. Left 3, down 4 is right here. Over 1, up 1 on both sides. Over 2, up 4 on both sides. So now you see where that is. I could go over 3, up 9 on both sides. And then my graph would come down like that. So there it is. Let me just bring in the printed version of this so you can get a better look. Okay, so that's what it would look like, all nice and fancy and neat, which I can't draw with my pen. So that's what the graph should look like. Okay, page 5 brings us to the end of lesson 21. Review the lesson summary and go to your problem set.